Hey everyone, this lesson is going to cover Unit 2.07 on triangles. Okay, we're going to look at how to classify triangles by their sides, their angles, and what is the angle sum theorem of triangles. So we want to be able to identify the type of triangle and also find the angle, its angle measurements. So some important definitions to keep in mind as we go through this lesson is we have an acute triangle, which this is a triangle that has all three angle measurements are acute angles. So they're less than 90 degrees. An obtuse triangle is a triangle that's going to have one obtuse angle or one angle that's greater than 90 degrees. A right triangle is a triangle that has one right angle. And then also this triangle angle sum property, which is also referred to as the angle sum theorem. The sum of the measures of all of the angles of any triangle has to add up to equal 180 degrees. So these are also all important key definitions to keep in mind as we go through this. So a triangle is a polygon that has three sides and three angles. And then I'll move picture back. On the left over here, we have an example of what a triangle looks like, which we all know what a triangle looks like. But now we're going to classify, the sides of the triangle and the angles. So looking at this triangle, we could say that from A to B is one side of the triangle, from B to C is one side of the triangle, and then from A to C is another side. Also, we can say that this triangle has three angles. We've got angle A right here, angle B right here, and then angle C over here. When you're constructing a triangle, you have to make sure that the sum of the two smaller sides of that triangle have to be larger than the third side. Okay, what that means is if you have the measurements of each side of that triangle, you're going to take the two smaller sides of that triangle, you're going to add them together. You want to make sure that the two smaller sides are going to add up to equal a number that is larger than that last side. Okay, so two examples of these, we can see that this first red triangle, the measurements are going to add up to equal a number that is bigger than 12 centimeters. However, on this triangle to the right, the two smaller sides are not going to add up to equal a number that is greater than 6 inches. So this would not be an example of a triangle, and we'll look at that in more detail right now. So the two smaller sides of this red triangle are 7 centimeters and 8 centimeters. When we add those numbers up, we get a total of 15 centimeters. So we would say that 15 centimeters is greater than 12 centimeters, which means that this is also an example of a triangle because those two smaller sides are going to add up to a number larger than 12 centimeters. This triangle to the right, however, we can see we have the two smaller sides of 2 inches. So 2 inches plus 2 inches is going to give us 4 inches. Okay, 4 inches is not greater than 6 inches, which is the larger side. So this is not an example of a triangle. This would not work. Okay, let's look at some more examples of this. If we have these measurements here, before we even have any pictures of the triangles, we can look at these measurements and decide, are these going to add up to equal to form a triangle? So in this first example, we've got 14, 18, and 35 feet. If we took the two smaller sides of 14 and 18 feet and added them together, would we get an answer that is greater than 35 feet? And the answer is no, okay? Same thing with number two smaller sides, 2 plus 12. Would we get an answer that is greater than 16? And then number 3, 17 and 32. Would we get an answer that is, or I'm sorry, 17 and 17. Would we get an answer that is greater than 32? So you can see here, if we take these two smaller sides for this first triangle, 14 feet plus 18 feet, we get an answer of 32 feet. 32 feet is not greater than 35 feet, so this would not form a triangle. These measurements would not work to form a triangle. Question number 2, 10 plus 12 is the two smaller sides. This would give us an answer of 22. 22 is greater than this larger side of 16, so this would work. These measurements would work to form a triangle. And number 3, we have 17 and 17 as our smaller sides. 17 plus 17 will give us an answer of 34, and 34 is greater than 32. So yes, this would also work to form a triangle. Okay. The next piece of information we're going to look at is classifying these triangles by either their angles and or their sides. Okay, so if we're classifying the triangles, and I'm going to break this down a little bit smaller, so we're only going to focus on the angles and then we're going to focus on the sides of those triangles. Okay, but this is a great chart to use just to have an overview of how to classify each of those by either the angles or the sides. So if we're classifying by angles, looking at this blue triangle here, we're looking at an acute triangle. What this means is that all of the angles of this triangle are classified as acute angles. And remember, an acute angle is any angle that measures less than 90 degrees. So 89 degrees is an acute angle. Okay, anything less than 90 degrees. In this case, this triangle, all 3 of these angles are acute angles. None of them are bigger than 90 degrees. Okay, so this would be an acute triangle. Over here, we have an obtuse triangle, which means that only one of the angles of this triangle is going to be classified as an obtuse angle. Okay, so only one of the angles has to be classified, not all of them. Okay, only one. So an obtuse angle, remember, is any angle that measures greater than 90 degrees. So 91 degrees is an obtuse angle. In this case, this obtuse triangle is going to have one angle that is greater than 90 degrees. And then down here we have our right triangle. Our right triangle is going to have one of those angles is going to be measured as a 90-degree angle or as a right angle. Okay, only one of them has to be a right angle for it to be a right triangle. So a key difference between all of these is an acute triangle, all of the angles have to be acute. And then when you're looking at obtuse and a right triangle, only one of those angles needs to be either an obtuse angle or a right triangle to classify it as a obtuse or right triangle. Okay. Looking at classifying triangles by sides, okay, and I use these different colored tallies to kind of indicate if the sides are equal to one another, just to kind of help show you. So in this first one, we have a scalene triangle. We can see that we have a red, pink tally here on this larger side. We have 2 green ones on this side, and then we have 3 blue ones here. Okay, so each one of these sides we can see are going to be different measurements, different lengths. So a scalene triangle, all of the sides of the triangle are going to be a different length. There are no congruent sides. None of the sides will equal to each other. So let's say we had a 3, 4, 5 triangle. Though all those side lengths are different, it would be a scalene triangle. Over here, we have an isosceles triangle. We could see we've got 2 green tallies on this side. We also have 2 green tallies on the other side as well. And then we have about a pink one at the bottom. So the isosceles triangle is going to be 2 sides of that triangle are going to be the same length or congruent, and then one side is different. So isosceles, only 2 of the sides need to be the same length. An equilateral triangle, think of equilateral sounding like equals. All of the sides of this triangle have to be the same or congruent. So they would all have to be equal to 2, or they would all have to be equal to 10. They all have to have the same measurement. Okay. So looking at these triangles here, we want to classify each of these triangles by both its angles and its sides. So we want to first look to see what kind of angles each of these triangles have. We can say that this first triangle, we see that we have 40-degree angle and a 24-degree angle that are labeled. But this last angle, if you kind of turn your head and you maybe turn the picture a little bit, you can see that that last angle is going to be greater than 90 degrees. So we could say that that's an obtuse angle. We can also say that each of those side lengths appear to be different, even though they're not measured, they don't have measurements listed. We can see that they are going to be different in length if they were labeled. So we would say that this is going to be a scalene triangle. Okay. This second triangle, we've got this box in the corner that tells us that this is a 90-degree angle, which means that if there's one 90-degree angle, we could say that this is a right triangle. And then we've got two sides that are labeled as 5 centimeters, which means two sides are equal to one another. So we would say that this is also an isosceles triangle. A couple more practice questions just to kind of look this over. So in question number 1, we can see that there is this box again that tells us this is a right triangle. Okay, so we would say that this is a right triangle. And then we could see that each of these sides is labeled with a different measurement. So that means none of the sides are equal. It means that this is a scalene triangle. Question number 2, we can see that each of these angles that are labeled as 27 degrees, but then this last angle does look to be, it is greater than 90 degrees. So we would say this is an obtuse angle. Okay, so that means it's an obtuse triangle. And then we can see with these tally marks again that this is telling us that both of these sides are equal to one another, which means that two of the sides are equal and one is different. So that means it's an isosceles triangle. Question number 3, we can see that we've got a 60-degree angle and a 60-degree angle labeled. This last angle, you can look at that and you can see that that's not going to be bigger than 90 degrees. So we would actually say that all 3 of these angles are less than 90 degrees. So it's an acute triangle. And then each of these sides has a tally mark showing that they are all equal to one another, which means that all sides are equal. It's an equilateral triangle. And then the last question, number 4, we can see again, we have this box in the corner telling us we have a 90-degree angle. So it's a right triangle. And then we can also see that we have two sides labeled as 9. And then this last side, even though it's not labeled, we can see that it's going to be a different length. So we would say that two sides are equal, one is different. So this is an isosceles triangle. All right. The next thing, or actually we're going to look at one more example. So if we wanted to classify this triangle by its angle measures, you can look at each one of these angles. We've got a 40-degree angle, a 65-degree angle, and a 75-degree angle, which means none of these angles are greater than 90 degrees. So we would say that the answer to this would be it is an acute triangle. All of the angles of this triangle are less than 90 degrees. In this question, we've got two angles that are labeled as 95 degrees and 53 degrees. Even though this last one's not labeled, we can look at this 95-degree angle and we can say this is greater than 90 degrees, which means we have one obtuse angle, which means that this triangle is going to be an obtuse triangle. One angle, only one, has to be greater than 90 degrees for it to be an obtuse triangle. All right. The last thing I want to look at as far as triangles go is what's called this angle sum theorem. This theorem states that the sum of the measures of all three triangles, all three angles of any triangle is always going to be equal to 180 degrees. So we're saying the measure of angle A plus the measure of angle B plus the measure of angle C is all equal to 180 degrees, always with triangles, okay? So let's take a look at this and what this means. If we have this first example, we've got 64 degrees and 35 degrees, and then we have one angle that's labeled as X. We want to figure out what this missing angle is. And how we do that is we can set this up as an equation, okay? If we set this up as an equation, we're going to do 64 degrees plus 35 degrees plus X is all equal to 180 degrees, because that's what the angle sum theorem tells us it's equal to. So we set it equal to 180. Okay, then you can combine like terms. We could say 64 plus 35 will give us 99. So we can write this again, 99 plus X is equal to 180. And then we want to subtract 99 from both sides because this 99 was positive. So we want to figure out what X is equal to by using the inverse operation. 99 minus 99 will cancel, and then 180 minus 99 will give us an answer of X is equal to 81. That means that this missing angle of this triangle is 81 degrees. Okay. This next example, we've got two angles that are labeled 34 degrees and 122 degrees. So we set this up as an equation. 34 degrees plus 122 degrees plus this missing angle of x is all equal to 180 degrees. If we add 34 plus 122, we would get 156 plus x is equal to 180. We want to subtract 156 from both sides. We get x is equal to 24 degrees. This missing angle here is 24 degrees. All right, let's look at some more examples. So we've got this first triangle here. We've got two angles that are listed as 56 degrees and 59 degrees. So we're going to do the same thing. We're going to set up that equation. We would do 56 plus 59 plus x is equal to 180 degrees. Okay. 56 plus 59 plus x. If we combine like terms, 56 plus 59, we get 115 plus x equals 180. Subtract 115 from both sides to do the inverse. We get a missing angle measurement of x is equal to 65 degrees. Number 2 over here, we've got only one angle is labeled. However, because this little box is in this corner, we know that this angle over here is equal to 90 degrees. So even though it's not listed as 90 degrees, we know it's 90 degrees, so we could still set this up as an equation. 67 plus 90 degrees plus x is equal to 180. If we combined like terms, 67 plus 90 will give us 157 degrees plus x is equal 180. And then we subtract 157 from both sides and we get this missing angle of 23 degrees. All right. Couple more practice questions to look at. Again, do the same thing, okay? I'm going to go ahead and pause for a second and let you guys try this out before we continue. Maybe if you have a piece of scratch paper, just try what we've been doing as far as figuring out what that last angle measure is. Set up an equation and set everything equal to 180 degrees. All right, I think I paused long enough so we can get the answers to at least number 3. Maybe I'll pause for another second if you're working on number 4. All right, so this is how we're going to do both of these questions. Set them equal. 15 plus 19 degrees plus x is all equal to 180. Okay, 15 plus 19 will give us an answer of 34. We write this as 34 plus x equals 180. And then we want to subtract 34 from both sides to figure out what x is equal to. We find that we have a missing angle measure of x is equal to 146 degrees. Question 4, we've got 63 degrees and 41 degrees. So we're going to add that with x, set it equal to 180 degrees. 63 plus 41 is going to give us 104 plus x is equal to 180 degrees. And then we're going to subtract 104 from both sides, and we get this missing angle measure of x is equal to 76. All right. What about this one? If we know that angle B is 90 degrees and angle C is 48 degrees, we want to figure out what angle A is going to be equal to. So we're going to do the same thing. We're going to do 90 plus 48. You can label angle A as X. Set it as X for now because that's our unknown measurement. we get 90 plus 48 plus x is equal to 180 degrees. 90 plus 48 will give us 138 degrees. And then we want to subtract it from both sides. 180 minus 138 will give us an answer of x is equal to 42 degrees. We can also look at this triangle and we can say that it's got a 90-degree angle, so we know that it's a right triangle. That's if it was, we were classifying by those angle measurements. What about this one? This is kind of a challenge question. This is going to be a challenge question. We've got these two triangles. We know that this triangle here, all of these angles here can be added together to equal 180 degrees. However, only one of these angle measurements is listed for us. We don't know what angle 1 or angle 2 is. This triangle up here, we know that these three angles can be added together to equal 180 degrees. The good thing about this triangle up here is that angle 3 is our only missing angle. So let's start there. Okay, let's start with angle 3. Okay, since we know the other two angles of that triangle, that's why we're going to start with angle 3. Even though it's listed as the missing angle measure of 1, 2, and 3, as long as we can start backwards, it's okay. We're still going to get, the correct answers. So if we solve for this angle 3, we get 68 plus 33, because these are the two angle measurements of this triangle, plus x is equal to 180 degrees. 68 plus 33 will give us 101 plus x equals 180. And then we're going to subtract 101 from both sides, and we find out that angle 3, the measurement of angle 3 is 79 degrees. Okay, so this missing angle is 79. The next thing we want to do is we're going to look at the missing angle for 2. Okay, the reason why is in a couple lessons back, we talked about vertical angles. Okay, vertical angles are always congruent. They're always going to be equal to one another. So in this case, we know that this angle here is 68 degrees. We know that this angle is vertical to angle 2. That means that since they are vertical angles, they are equal to one another. So we know that the measure of angle 2 is going to be 68 degrees. The last thing we're going to do is we're going to solve for angle 1. Okay, we know that the other two measurements is 68 degrees and 93 degrees, so all we have left to do is solve for angle 1. We're going to add these up and set them equal to 180, okay, because this is a separate triangle from the one we did above. It is separate. Okay, 68 plus 93 plus x will give us 180. 68 plus 93 will give us 161 plus x equals 180. And then we're going to subtract 161 from both sides to get our missing angle 1 of 19 degrees. Okay, so this last angle will give us 19. All right, let me go back real quick. So this is 19. These class notes will be posted on our content section, so that if you would like, you can always go through and look through those to see these examples again. I encourage you to use this to help you as well. There's the breakdown of all the examples. Kind of went through everything. If you have any questions, please send me an email. I will be happy to help with this information. And then we also have those help sessions that I encourage you guys to come, and be a part of, and ask questions, if you need it, or if you just want to come hang out. I encourage you to do so. All right. You guys have a great day. And thank you for watching this.